right, my friends, let's see how it went for you. For this problem, truth is I don't really know if it matters what you let u equal, whether you let equal e to the x or sine of x. Probably works out either way, to be honest with you, because both functions are considered cyclic functions. They kind of have a repetitive cycle when you take their derivatives and antiderivatives. But I like doing this one with letting u equal e to the x and then dv equaling the rest, so sine of x dx. So du would be e to the x dx, and then v, let's see, would be the opposite of cosine of x. Okay, so one thing, if you got lost in this problem or if you started feeling hopeless because of the infinite cycles that both functions have, then one thing I could do to help you keep this one straight would be to possibly change your formatting. So, and this is how you could change it. Prompt your work with this integral that you're finding. So like this. And it's such a simple little thing, but it actually is going to make the way this thing works out in the end, it should make it make a lot of sense if you just add that to prompt your work, okay? So now let's go ahead and show round one of integration by parts. So u dv, oh, sorry, u times v, that is. Wow, that came out funny. U times v minus the integral of v du. Okay, now I'm just going to clean it up a little bit. Makes me feel like I'm accomplishing something. Anyway, for this integral here, I'm going to write it in kind of the same order the original was in, where e to the x is first. Like that. Okay. And it might be about now that people start feeling that yucky feeling, like, oh, this could last forever. But actually, it's the cyclic nature of this problem that's going to make it doable. So how many rounds of integration by parts will we need? Some people think infinitely many, and this thing will never end. And I can see why you'd think that. But the truth is we actually are just going to need one more round of integration by parts. So let's show that. So I'm going to let a equal, oops, that's not an A. Here. A, oh, that's not an A. Where's my eraser? What? Oh, good night. Okay, let A equal e to the x, and then we're going to let db equal cosine x dx. All right, dA and b. Oops, I forgot my dx. Okay, all right, here we go. Bring down the opposite of e to the x times cosine of x. And now let's go ahead and expand what this integral would be according to our second round of integration by parts, okay? A times b minus the integral of b dA. Okay. And then I'm going to take one step and clean things up. Okay, and if you're not sure where I'm going with this, then what I'm going to recommend is that you bring this prompt down, because this whole time what we're getting is supposed to be the answer to this. Okay. Oh, except I have a typo. Sorry. That was not going to work. There we go. That should be a minus right there, guys. All right. Now what I'd like for you to do is look, if this hasn't occurred to you yet, look at this line of work. Look at this equation, almost as if you're in Algebra 1 again. And look for a really calculus-y looking like term. And yeah, these integrals are the same. And so in this problem, we're going to take advantage of the infinitely cyclic nature, and you just do integrals until you get the integral that you were looking for. And then you can seriously like add the integral to both sides. All right, and what would we have? If you have one integral of e to the x sine of x dx and someone gives you another one, what do you have? You have two of them. I'm just going to copy down what we'd have left on the right side. And then when we're moving, you have your answer. We're just going to divide both sides by 2. So we'd have negative 1/2 e to the x cosine of x plus 1/2 e to the x times sine of x. And then now that we're all done, let's make sure we tack on a plus c there. There we go, my friends. I hope this makes sense. All right. So one big thing that I want to make sure that you walk away from with all this is, when should you use integration by parts? So in general, when nothing simpler works. And then in addition, a trigger is that your integral has a product of two functions of x inside, or in the case of, let's see, where was it? In the case of this one, your integrand wasn't really a product of two functions of x. I mean, you could think of dx as a function of x, I suppose. But the point was that your integrand was something that you know the derivative for. Your entire integrand was something that you knew the derivative for. And that is the other trigger to use integration by parts. All right, my friends, I hope this makes sense. I hope your homework goes well, and I hope you'll ask me questions if things don't seem to be going well for you.